Hello everyone and welcome to our demonstration. We developed a customer churn for telco under supervised learning. As dataset, we have found dataset that have information about telecom service provider who provide internet and home phone services. And this is the dataset we have found. So if we consider the size of dataset, it has around 7,000 rows and 21 columns. So it's a really complex dataset. So as a team, we did the data pre-processing part as a team, but for the demonstration purposes only, I will demonstrate it. Okay. So here I imported the dataset. We imported the dataset here, and we read the CSV file. So we take a quick look at a few rows of data here. You can get a small idea. So if you get the overall shape of dataset, we have 7,043 rows and 21 columns. After that, we get a small summary of numerical values of the data. So we get the count, mean, standard deviation, likewise. After that, we get the data types of each and every column. So you can see a custom ID object, gender object, and you can see all the data types of each and every column. So here, if you check the data set, our total charge has float values. So, but our it shows us type as object. So we have to convert it to numeric value. So here after that, because of that, we convert it to numeric value. So after that, we check if it was changed. So you can see here our total charge was changed to floating value. So after that, we got a count of null values of column. So you can see here only total charge has 11 null values, 11 rows of null values. If you check it here, check the locations of null value, you can see it here. Total null values, all the level null values. Then before we fill up the null values, because we can't keep the null values for training model. So before we fill up the null values, we just checked outliers. You can see it here. So now we fill the null values because we can't keep null value for training data set. So we fill up the null values and we get the mean. Mean of we get the mean value. So you can after that we check the changes are made. So total changes are made. So we need in here we remove unnecessary columns. We can see we have, if you check the data set, we actually don't need the customer ID column because it doesn't relate to customer churn. So we remove it. So next we check the correlation of columns with other columns. So basically we visualize the count of churn and non-churn values with each and every independent variable. So basically we are doing here is checking the correlation of churn column with other columns. So you can see the generated graphs here with gender column, senior citizen column, partner, dependents, and phone services likewise. Now we convert churn column to a numerical value. In our churn column, it has object value has objects as if you check the data set, we have churn column yes or no value. We need to convert it to 1 or 0 values. So in here we converted that. You can see it here. After that, we get the dummy data frame to convert categorical variable into numerical variable for further analysis. If you check the data set here, we have gender column under gender column we have male, female, and under partner column we have yes or no. Under dependent column we have now. Oh yes, likewise we now we change it to a numerical variable. After that we get this new dummy data frame. You can see here we have separate column for gender female, gender male, and another separate column for gender male, another column for partner no and partner yes. So now we have 46 columns. So now we check this 40 correlation with churn columns plotting for each and every variable in dummy data frame. We check all 46 columns correlation with churn column. You can see the graph here we generated. And now we mm, create a CSV file with our preprocessed dataset. Now we import our necessary views, and now we read the new CSV file. When we read the new CSV file, we can hear it will auto-generate the unnecessary unnamed column. We don't need that. So we removing the auto-generated unnamed column. So here we get the dependent and independent variables. After that, we break the data into test and train set. So for testing purposes, we get 20% of data. For training purposes, we get 80% of data. So after that, we checking how many churn and non-churn customers are there. You can see here in this graph, around 2000 and 5000 unchurned, around 5000 unchurned customers. So here we check the balance of data set to show us as 73 to 26. We can't keep it here. We have to resample it. So after we resample, uh, we need to get closer to 50-50. Previously we had a 75 to 25. We need to bring it closer to 50-50. So after we resample it, it will get it will got us 54 to 45. So this is my training 45 model. So this is my model, logistic regression model. I imported a logistic regression model, and here after that I create the model. After that, I get the prediction for before resampling. We got resample before resampling it. We get the model accuracy as 80%. So if you get the classification report, you can see it here. We got the 81% accuracy before resampling. But we get accuracy after resampling. After that, I got the score after resample. So in here I got score after resample, and that after that I got accuracy for 94%. So after that I got a classification report. You can see it here. We have a accuracy of 95%. So if I after that I got the confusion metrics here. Uh, in here we can see we true positive, false positive, true negatives, and false negative. We have a large number of true positives and also large number of uh, false negatives, and very small number of false positive and false negatives. So it will shows us our model performed really well. So that's all for my part. Thank you.
Hello, my name is Dilashan Yoketi and my ID number is IT20 124526. My leader gave me introduction about our data processing of our project, and I also involved for the data processing implementation also. In the algorithm modeling part, I just use random forest classification with supervised learning method for the my model building. And here, first of all, it initialized the random forest model using a random forest classification, and also I just feed the my training data to the our model, and we just took 80% training to the training data for 80% and testing for the 20% data. And here we just take a prediction of the our testing data on according to the trained training model, and here also take a accuracy of the our training data set, which is according to the trained our random forest model. And I just display classification report, which is including the other necessary value also, to the our testing data. It may containing 81 percent accuracy for the uh, model, and also it uh, it take only testing data predictions. And here we just use resampling technique for the address for the class imbalancing issue. Here also I display the percentage wise the resampling value, which is including the churn and unchurn attributes. Uh, in here, same as the earlier that I mentioned. Here also we just train for the model to the our resampling data set. In here, same as earlier, fit the resampling data set to the model, and took a rough accuracy of the resampling testing dataset using score method. And here also I predict the resampling dataset using resampling testing dataset for the uh, rest rest coding. And just take a classification report, which is necessary dataset earlier, that is which is displayed earlier. And here also contain uh, resampling testing dataset and resampling predicted value, which is calculated earlier code part. And just for the conclusion matrix, we just use for display performance of the our classification algorithm. Here it just display as a matrix. And here same part of the conclusion matrix, I use heat map plotting for the display that conclusion matrix uh, using heat map plotting method. uh, that's all my part. Thank you very much.
Hello, uh, my name is Deshan KBGL. My IT number is IT20151188. This code builds a decision tree model to classify data into different categories. First, the code initializes decision tree model using the criterion Gini and sets the random state to 0. Next, the model trained using training dataset, that is X-train and Y-train. The predictions are made on the dataset, that is X-train, using training model, and the accuracy score is calculated by comparing the predicted values, that is Y-pred, to actual values, that is Y-test. A classification report is printed to show the precision, recall, and the F1 score for each class. Uh, then the code performance resampling of the data to balance the classes using smooth techniques. The resample data is split into training and testing data sets, and the new decision tree model is trained to using resample training data. predictions are made on resampled test data, and the accuracy score and the classification report are printed again. Finally, confusion matrix is printed, which shows how many instances of each class were correctly or incorrectly classified by the model. Overall, this code shows the how to build and evaluate a decision tree model using both regular and resampled data. Thank you.
Hello, I am Manjana Crossing. Uh, as earlier mentioned, I also contributed to the data preparation part, and the main contribution to this assignment is I developed the XGBoost model to gain churn prediction, customer churn predictions. Uh, So XGBoost is a gradient-based supervised learning approach. So in here, first of all, uh, import the XGB classifier from the XGBoost library, and in here, fitting the values for the XGB classifier for trained data. In here, the label encoder is already false because we are using preprocessed data with labels, so no numerical values. And in here we are make predictions on the input data. So we're using XGB classifier to predict the data using X testing data, and this command using to print a classification report from for the XGP classifier model. So in first classification report, I'm getting a F1 score accuracy of 0.93, and in here I'm resampling and creates a new XGP classifier for gain predictions again, and in here refitting the data into resampled classifier model, and again I'm printing the classification report from the resampled classification reports that gain predictions from the resampled uh, classifier model, and this time I'm getting an accuracy of 0.96, F1 score 0.96, and in this command I'm using to compute the accuracy score of the predictions made by XGBoost model, and I'm getting a 0.9627 uh, score to the score uh, to the XGBoost model, and in here I'm using to compute confusion metrics for the predictions made by XGBoost model.